Dear students, today we will see how to find the derivatives of inverse trigonometric functions. Okay, let us start with the sine inverse x. Sine inverse x. I want to say what is the derivative of sine inverse x. Of course, by using the first principle you can get it. Now let us try to find the derivative of sine inverse x by using chain rule, by using the derivatives of composite functions. I'll take this as y. Let y is equal to sine inverse x. Then according to the definition, this will imply that x is equal to sine y. X is equal to sine y. Now let us differentiate this with respect to x. Differentiating this with respect to x, that will give you 1 is equal to derivative of sine y is cos y into dy by dx. I am using chain rule here, observe. If it is, since I am differentiating it with respect to x, derivative of sin x is cos x. Derivative of sin x with respect to x is cos x. Derivative of sin y with respect to x is cos y into dy by dx. Actually, say if you have y is equal to sin x, and if I ask you to differentiate this with respect to x, we will directly write cos x. Actually, it is cos x into dy by dx of x into the dy by dx of x. It means derivative of x with respect to x. So I am using chain rule. First we are differentiating for the sine, then we are differentiating for that x. Okay. So here what happens? Into dy by dx of y, which is nothing but dy by dx. Okay. So from this I can write dy by dx is equal to 1 by cos y. Okay. Now I want the answer in terms of x. So express cos y in terms of x. X is sin y. I try to express cos y in terms of sin y. I can write like this. Cos y can be written as root of 1 minus sin square y. Because you see, cos square y plus sin square y is equal to 1. Cos square theta plus sin square theta equal to 1. So cos square y can be written as 1 minus sin square y. Hence cos y is equal to square root of 1 minus sin square y. Sin y is equal to x. So sin square y is equal to x square. So from this we get dy by dx is equal to 1 by root of 1 minus x square. Dy by dx equal to 1 by root of 1 minus x square. So dy by dx, what is y? Y is sin inverse x. From this I can write that dy by dx of sin inverse x is equal to 1 by root of 1 minus x square. Remember this formula. So earlier you have prepared one list containing the functions and their corresponding derivatives. Include this in your list. All will be using this in solving the problems. Derivative. So you must remember that the derivative of sin inverse x is 1 by root 1 minus x square. Okay. Then let us look at the derivative of cos inverse x. I take y is equal to cos inverse x. By definition, I can write x is equal to cos y. Now I am differentiating with respect to x. Differentiating with respect to x, we get 1 is equal to derivative of x with respect to x is 1. Derivative of cos y with respect to x is minus sin y into dy by dx. Derivative of cos y is minus sin y into dy by dx. That will imply that dy by dx is equal to minus 1 by sin y. Dy by dx equal to minus 1 by sin y. Now I want to express this in terms of x. Say x is equal to cos y. We shall write sin y in terms of cos y. So it will become dy by dx is equal to minus 1 by sin y. I can write it as square root of 1 minus cos square y. 1 minus cos square y is sin square y, root of that is sin y. So we have dy by dx is equal to minus 1 by root of 1 minus cos square y. So I can write dy by dx of y. What is y? Cos inverse x. That's equal to, sorry, I'll write one more step here. Minus 1 by root of 1 minus cos square y. Cos y is equal to x. So cos square y is equal to x square. So derivative of cos inverse x is minus 1 by root of 1 minus x. Derivative of sin inverse x is 1 by root 1 minus x square, and derivative of cos inverse x is minus 1 by root 1 minus x square. Okay, then now I'll consider tan inverse x. Let y is equal to tan inverse x. This will imply that x is equal to tan y. Y is equal to tan inverse x will imply x equal to tan y. Now differentiating with respect to x. Differentiating with respect to x, we get 1 is equal to secant square y into dy by dx. Derivative of tan x is secant square x. So derivative of tan y is secant square y into dy by dx. From this I can write dy by dx is equal to 1 by secant square y. Okay, 1 by secant square y. Now I want to express secant square y in terms of tan. Secant square y, I want to express it in terms of tan. Secant square y can be written as 1 plus tan square y. Secant square y is nothing but 1 plus tan square y. So dy by dx is equal to 1 by 1 plus tan square y. Tan y is equal to x. So tan square y is equal to x square. Dy by dx is equal to 1 by 1 plus x square. Therefore, dy by dx of y, what is y? Tan inverse x. dy by dx of tan inverse x is equal to 1 by 1 plus x square. Derivative of tan inverse x is equal to 1 by 1 plus x square. Okay. After this, I will go for cot inverse x. Let y be equal to cot inverse x. This will imply that x is equal to cot y. X equal to cot y. Now differentiating with respect to x, we get 1 is equal to, derivative of cot y is minus cosecant square y into dy by dx. Minus cosecant square y into dy by dx. This will give us dy by dx is equal to minus 1 by cosecant square y. Dy by dx, I am bringing it to this side. Dy by dx is equal to minus 1 by cosecant square y. Okay. Now, we shall express this cosecant square y in terms of cot y. Dy by dx equal to minus 1 by cosecant square y is nothing but 1 plus cot square y. Cosecant square y is equal to 1 plus cot square y. That formula we know. So dy by dx is equal to minus 1 by 1 plus cot square y. Cot y is equal to x. So cot square y is equal to x square. Dy by dx is equal to minus 1 by 1 plus x square. So therefore, dy by dx of y, what is y? Cot inverse x. dy by dx of cot inverse x is equal to minus 1 by 1 plus x square. So the derivative of cot inverse x is equal to minus 1 by 1 plus x square. Okay. Next, we shall look at secant inverse x. I take y as secant inverse x. Let y is equal to secant inverse x. Then by definition, x is equal to secant y. Now let us differentiate this with respect to x. Differentiating this with respect to x, we get 1 is equal to secant y into tan y into dy by dx. Derivative of secant x is secant x into tan x. Derivative of secant y is secant y into tan y into dy by dx. So from this we write dy by dx is equal to 1 by secant y into tan y. Okay, now I want to express them in terms of secant y, in terms of x, so in terms of secant y. I will keep this secant y as it is, and I will write the tan y in terms of secant y. Secant y I will keep it as it is. Tan y can be written as the root of secant square y minus 1. Root of secant square y minus 1. What is secant y? Secant y is equal to x. So I will write dy by dx is equal to 1 by x into root of x square minus 1. 1 by x into root of x square minus 1. Okay? Now, see, I wrote tan y as root of secant square y minus 1. You know this formula, 1 plus tan square y is equal to secant square y. So tan square y can be written as secant square y minus 1. So tan y is equal to plus or minus square root of secant square y minus 1. Okay? But here I wrote it as root of secant square y minus 1 only. So I can write this as plus or minus root of x square minus 1. Instead of that, I can write this x as mod x. dy by dx is equal to 1 by mod x into root of x square minus 1. When x is positive, it will be 1 by x into root x square minus 1. When x is negative, it will be minus 1 by x into root x square minus 1. How it is, I will show you. See, I have defined y is equal to secant inverse x. The domain of secant inverse x is, what is the domain of secant inverse x? It is minus infinity to minus 1, union 1 to infinity. Okay? Clearly, this is not differentiable at minus 1 and at plus 1. So, either x should be less than minus 1 or x should be greater than 1. Okay. Now when I take x greater than 1, the range of secant inverse x. So what is the range of secant inverse x? Range of secant inverse x is closed interval 0 to pi except pi by 2. Okay? Closed interval 0 to pi except pi by 2. So now when x is less than minus 1, if I take x is less than minus 1 means x is negative. So here x, this secant inverse x, y lies in this interval 0 to pi minus except pi by 2. So either in the first quadrant or in the second quadrant. When x is negative, that means this y will be in the second quadrant. When y is in second quadrant, what happens here? You just observe. When y is in second quadrant, secant y will be negative. Right? Therefore, I will write mod x here. We will get the derivative as 1 by, and this tan y is also negative. You will get a minus root of secant square y minus 1. In other words, here minus root of x square minus 1 into, this will also be minus x. So minus x into minus root of x square minus 1, together it will become plus x. So it will become modulus of x. If x is positive, I can directly write 1 by x into root x square minus 1, because when x is greater than 1 means y lies in the first quadrant. Y lies in the first quadrant means secant y is positive, and therefore tan y is also positive. tan y is positive, secant y both are positive only. Secant y is positive, tan y is positive. So it will simply be 1 by x into root x square minus 1. Okay. See, when x is negative, it will become minus 1 by x into root x square minus 1. When x is less than 1, negative means x is less than minus 1, it will be minus 1 by x into root x square minus 1, the derivative. And when x is greater than 1, it will be 1 by x into root x square minus 1. So if I write 1 by mod x into root x square minus 1, both will be covered. Okay. For x less than minus 1 or for x greater than 1, the derivative of secant inverse x is 1 by mod x into root x square minus 1. d by dx of y is secant inverse x, that is equal to 1 by mod x into root of x square minus 1. Okay, if you have understood that, well and good. If not, then also as far as PUC is concerned, you need not worry about anything else. Just remember this formula. Derivative of secant inverse x is equal to 1 by mod x into root x square minus 1. These proofs will not be asked in the examination. You will need to remember the formula. We will be using this formula in solving the problems. Okay. Now let us go to cosecant inverse x. Let y is equal to cosecant inverse x. Then this implies x is equal to cosecant y. Y is equal to cosecant inverse x will imply x is equal to cosecant y. Differentiating with respect to x, we get 1 is equal to derivative of cosecant y is minus cosecant y into cot y into dy by dx. So from here I can write dy by dx is equal to minus 1 by cosecant y into cot. Okay. Cosecant y I will keep it as it is. So dy by dx is equal to minus 1 by cosecant y into root of cot y. Cot y can be written as cosecant square y minus 1. Root of cosecant square y minus 1. So dy by dx is equal to minus 1 by x into root of x square minus 1. Cosecant y is x. Therefore, dy by dx of cosecant inverse x will be equal to minus 1 by mod x into root of x square minus 1. When x is negative, it will become minus 1 by minus x into root x square minus 1. When x is greater than 1, that is when x is greater than 1, it will become minus 1 by x into root x square minus 1. So, just like the derivative of secant inverse x, here also we write modulus of x. So, derivative of cosecant inverse x is equal to minus 1 by mod x into root of x square minus 1. This formula you have to remember. So let us say I'll write one table here, the function and their derivatives. You include these formula in your list which we have prepared earlier. Say d by dx of sin inverse x, derivative of sin inverse x is equal to 1 by root of 1 minus x square. Derivative of cos inverse x is equal to minus 1 by root of 1 minus x square. Derivative of tan inverse x is equal to 1 by 1 plus x square. Derivative of secant inverse x is equal to 1 by mod x into root of x square minus 1. Derivative of cosecant inverse x is equal to minus 1 by mod x into root of x square minus 1. Then derivative of cot inverse x, d by dx of cot inverse x is equal to minus 1 by 1 plus x square. You need to remember all these formulas. Okay, now let us solve a few problems. Question is same, differentiate the following functions with respect to x. Differentiate the following functions with respect to x. First question, cos tan inverse x. Cos of tan inverse x. I'll take this as y. Let y is equal to cos tan inverse x. Now y dash, the derivative of this is. This is like cos x. Derivative of cos x is minus sin x. So derivative of cos tan inverse x is minus sin tan inverse x. Derivative of cos x is minus sin x. In place of x I am writing tan inverse x into the derivative of tan inverse x into d by dx of tan inverse x. That's equal to minus sin tan inverse x into the derivative of tan inverse x. What is the derivative of tan inverse x? 1 by 1 plus x square. That's the answer. Derivative of tan inverse x is 1 by 1 plus x square. Okay. Let us look at the next question. The next question is tan inverse of x square plus 1. Tan inverse of x square plus 1. We want the derivative of tan inverse x square plus 1. I'll call it as y. Let y equal to tan inverse of x square plus 1. I want the derivative of this. Derivative of tan inverse x is 1 by 1 plus x square. So derivative of tan inverse of x square plus 1 we want. In place of x we have x square plus 1. So now y dash is equal to 1 by, see derivative of tan inverse x is 1 by 1 plus x square. Derivative of tan inverse x square plus 1 is 1 by 1 plus x square. In place of x we have x square plus 1 whole square into the derivative of x square plus 1. 1 by 1 plus x square plus 1 whole square into the derivative of x square plus 1. What is the derivative of x square plus 1? Derivative of x square is 2x. Plus the derivative of 1 which is 0. So 2x, 2x by 1 plus x square plus 1 whole square. Next question. Sin inverse of root x whole power 18. Sin inverse of root x whole power 18. I'll call this as y. Let y is equal to sin inverse root x whole power 18. Okay? This looks like y is equal to x power n. When y is equal to x power n, its derivative is n into x power n minus 1. So the derivative of sin inverse root x whole power 18 is 18 into sin inverse root x whole power 18 minus 1 which is 17 into the derivative of sin inverse root x into d by dx of sin inverse root x. That's equal to 18 into sin inverse root x whole power 17 into the derivative of sin inverse root x. What is the derivative of sin inverse x? 1 by root 1 minus x square. So now in place of x we have root x. So the derivative of sine inverse root x would be 1 by root of 1 minus x square. In place of x we have root x. So root x whole square into d by dx of root x into the derivative of root x. That's equal to 18 into sine inverse root x whole power 17 into 1 by root of 1 minus root x whole square, it will become x, into derivative of 1 by root, derivative of root x is 1 by 2 root x. Okay, this is the answer. Next, sine inverse of x by a. Sine inverse of x by a. I got it as y, and y is equal to sine inverse of x by a. Now let us differentiate this. Y dash is equal to derivative of sine inverse x is 1 by root of 1 minus x square. So derivative of sine inverse of x by a is 1 by root of 1 minus x square. In place of x we have x by a whole square into the derivative of x by a. Into the derivative of x by a. That's equal to, let us simplify this. This is x square by a square. I will take LCM. It will be a square. Numerator will be a square minus x square. Derivative of x by a is 1 by a. Because 1 by a is a constant, derivative of x is 1. 1 by a into 1 will give you 1 by a. Simplify this a square comes outside the root, it will be 1 by a goes up to a gets cancelled. So you will have y dash is equal to 1 by root of a square minus x square. 1 by root of a square minus x square. Next question. E power m cos inverse x. E power m cos inverse x. So as always I will take this as y. So y is equal to e power m cos inverse x. Okay. This is of the form e power x. What is the derivative of e power x? Derivative of e power x is e power x itself. So e power m cos inverse x into d by dx of m cos inverse x. So it's not necessary that in every problem you should write d by dx of that and then differentiate it. You can directly differentiate also if you can understand it. So now I will write it directly because we have solved enough problems on chain rule so as to get to know directly. If I write, I think you will be able to understand. Okay. So e power m cos inverse x into the derivative of m cos inverse x. Here m is a constant and cos inverse x is a function. So that constant into function we have, we will keep the constant as it is and differentiate the function. Keep the constant as it is, m. Differentiate the function, derivative of cos inverse x. What is the derivative of cos inverse x? Minus 1 by root of 1 minus x square. This is the answer. Minus m into e power m cos inverse x divided by root of 1 minus x square. Next, tan inverse of e power x. Tan inverse of e power x. Let y equal to tan inverse e power x. This is of the form of tan inverse x. Derivative of tan inverse x is 1 by 1 plus x square. Now we have tan inverse of e power x. So its derivative is 1 by 1 plus x square. In place of x we have e power x whole square into the derivative of e power x. What is the derivative of e power x? E power x itself. So the answer is e power x divided by 1 plus e power 2x. E power x whole square. There is nothing but e power x into e power x, which will become e power 2x. Next question. Sin inverse of 2 cos x whole power 5 by 2. Sin inverse of 2 cos x whole power 5 by 2. Okay. So we will treat this as y. Let y equal to sin inverse of 2 cos x whole power 5 by 2. So this looks like y is equal to x power m, x power n. Derivative of x power n is n into x power n minus 1. So y dash will be equal to n is 5 by 2 here. 5 by 2 into sin inverse of 2 cos x to the power n minus 1. 5 by 2 minus 1, that will give you 3 by 2. Into what next? Into the derivative of sin inverse of 2 cos x. I will directly write here. Derivative of sin inverse of 2 cos x. Derivative of sin inverse x is 1 by root 1 minus x square. Here in place of x we have 2 cos x. So derivative of sin inverse of 2 cos x will be 1 by root of 1 minus x square. In place of x we have 2 cos x whole square into, it's not over yet, into, now the derivative of 2 cos x, there 2 will remain as it is. Derivative of cos x is minus sin x. Okay, that 2, this 2 will cancel. So the answer will be minus 5 sin x into sin inverse of 2 cos x whole power 5 by 2 divided by root of 1 minus 4 cos square x. Okay, 1 minus 2 cos x whole square is there, that I write as 4 cos square x. Okay, let us look at the next question now. Tan inverse of e power x into log sin x. Tan inverse of e power x into log sin x. Tan inverse e power x into log sin x. Okay. I will treat this as y. Tan inverse of e power x into log sin x. Okay. See here we have a product of two functions. This is one function, tan inverse e power x. Log sin x, this is another function. Okay. And this function tan inverse e power x, this itself is a composition of two functions, tan inverse x and e power x. Similarly, this is a composition of two functions. While differentiating this, we have to use chain rule, similarly this. But to differentiate this, we will use product rule first. Okay. So y dash is equal to product rule. This is the first function. I will call this as the first function and this is the second function. Now, if you want, you can reverse it also, no problem. So how do we differentiate the product of two functions? So if I have u, v, I want to differentiate this d by dx of u, v. This is equal to u into v dash plus u dash into v. That is first function into derivative of the second plus second function into derivative of the first. So now first function I will keep it as is tan inverse of e power x into, now I would like to differentiate the second function. Differentiate the second function. I want the derivative of log sin x. Log sin x, derivative of log x is 1 by x. So derivative of log sin x is 1 by sin x into the derivative of sin x, which is cos x, plus, see here what I did is first function into derivative of the second, plus second function which is log sin x into derivative of the first. I want the derivative of tan inverse e power x. Derivative of tan inverse x is 1 by 1 plus x square. So derivative of tan inverse of e power x is 1 by 1 plus e power x whole square into the derivative of e power x. Derivative of e power x is e power x itself. So this on simplification gives us tan inverse of e power x into cos x by sin x. Together I can write it as cot x plus log sin x into e power x divided by 1 plus e power x whole square. You can write it as e power x whole square or you can also write it as e power 2x. Okay. Next. Last problem of the day. E power tan inverse of cos root x. E power tan inverse of cos root x. Okay. Students, just like in all the other problems, we shall take this as y. Let y is equal to e power tan inverse of cos root x. Well, this is of the form e power x. As we all know that the derivative of e power x is e power x itself. So the derivative of e power tan inverse cos root x will be e power tan inverse of cos root x into what next? Into, now I will differentiate for this tan inverse of cos root x. Derivative of tan inverse x is 1 by 1 plus x square. So the derivative of tan inverse of cos root x will be 1 by 1 plus. In place of x, we have cos root x here. So we must write 1 by 1 plus x square. In place of x, I am writing cos root x whole square into the derivative of cos root x. Derivative of cos x is minus sin x. So the derivative of cos root x is minus sin root x into what next? Into the derivative of root x we want. What is the derivative of root x? Derivative of root x is 1 by 2 root x. Okay? Here this is equal to, we cannot cancel anything, minus e power tan inverse of cos root x into sin root x divided by 2 root x into 1 plus cos square root x. Okay? With this I will stop today's class. Thank you.